Hey everyone, welcome to this week's episode of the UnBuild It Podcast. This week we have the privilege of two outstanding sponsors in the building industry. First up, Huber Engineered Woods. They're the makers of Advantech and Zip systems. While I could sit here and give testimonials to each of their products, I'd much rather talk to you about Huber Engineered Woods as a company. As a sole proprietor, I need manufacturers that are team players. I need them at the beginning, the middle, and the end of projects to answer all my questions and help me provide the very best solutions to my clients' projects. Huber is just that team player, whether from a building science perspective or solving a sourcing question. They always have the answers I need. If you haven't used Advantech zip sheathing, zip bar sheathing, or their family of tapes and liquid flashings, there is no time like the present to team up with the pros at Huber Engineered Woods and start putting your buildings in a position for success. Second up, Benjamin Opdyke. Benjamin Opdyke is another team player that helps me solve problems. Through their team effort, we always develop solutions for placing my homes in a position for success. They offer an array of different venting and rain screen solutions to solve for my often challenging questions. Whether it's Home Slicker, Slicker Max, or the ever-tried and true Cedar Breather, their arsenal of products provide me the successful solutions I need. But the most important aspect of teaming up with a company like Benjamin Opdyke is knowing that I'm delivering long-lasting, durable solutions to my clients' projects.
Welcome to the UnBuild It Podcast. I'm Jake Bruton. Today I'm joined by Peter Yost.
Hey.
Say hi, Peter. And Steve Basic.
Hi, Steve.
I didn't even say hi, Steve, but he still did it. I like it. Dad joke to the max. Our topic today is something that I get questions about all the time, is blower doors and how we test. And I think that it makes sense for me to start us off with.
Well, hey, Jake, first, you should tell them there's another episode they have to listen to, eh?
Oh, yeah. If you after this episode or prior to this episode, it doesn't really matter. You got to go listen to Peter and I's interview with Gary Nelson that published a little while back. I think it's episode 19 of the UnBuild It Podcast. Gary, well, we can talk a little bit about Gary in a minute, yeah. But if you don't know who Gary Nelson is, you should if you're going to be concerned with blower doors in any way, shape, or form. So go and check out that episode. Thanks for reminding me about that, Pete.
Sure.
But see, this is where our process differs a little, because you want people to go back and listen to that one episode. See, I'm saying it's the year end. You should do a whole year in review and go back and listen to every episode 2 or 3 times between the holidays.
On different devices, too, because it gets us more downloads.
Yeah. And it's just because you will pick up something. You know, my jokes are sometimes so subtle. It's at least 3 or 4 listens.
Yeah, so subtle they don't come across as funny.
Yeah, I can't believe you learn something new every day from Mr. Basic. Every day.
Well, every day.
Okay, so I thought I would start us off talking about my first experience with blower door. I believe it was 2013. It may have been 2014 that I bought the IRC 2012 code, and I was reading some of the energy efficiency stuff and was kind of like, what is this blower door? And so obviously I used Google to figure out how blower door testing was working. And at that time, it didn't say mandatory in the code, I don't think. I think it, but I think it referenced a ResNet standard. And then I went and found that standard and figured out what a blower door was. And I called all of the insulators in my market. And then I called the city office and asked if they had an energy auditing program that I was unaware of. And they did. And I called the people they recommended for that, and none of them owned a blower door. And I was like, okay, well, nobody in my market owns one. Let's just buy this $2,000 thing and see if I can figure it out, which was quite a jump. I just was very curious. Excuse me. And
I'd say at 2K, you have to be very curious.
Yeah.
That's a pretty good price,
I was,
actually.
At the time, I believe it was the most expensive tool I owned besides a pickup. Like, I didn't own any job trailers. I didn't own any expensive table saws. I didn't own anything from Festool.
Wow, that's
like,
really
it
interesting.
was the most expensive tool I had ever purchased.
Big jump.
But I wanted to know, and I was super curious about it. And so I bought a DG 700 and quickly learned that I was going to have to fully understand the math because I'm a Mac user. And at the time, their portal system to connect it to the computer only did PC stuff.
Yeah.
And I was like, well, I just spent $2,000 on this blower door. I'm not buying a computer to be able to use it. So like the backside of my, and I still have it, the backside of the operating manual has all the math formulas written out on it so that it was like cheat sheet. So I didn't have to look them up each time. But that really educated me because it's, it's CFM, it's the volume of the building. Like it's all those things that the new doors do for you that like it made me understand better. And it was a couple years before I got a chance to blower door a new home just because we hadn't built one in a couple years. A lot of remodels, a lot of big additions. And that time, I had a 5,000 square foot addition, but that's not a new home. So that's hard to test. And it was enlightening though, because I tested the house that I lived in that was a 1960s ranch. I tested a house that we built for my parents in 1965, and they were identical in leakage and really close in size. And so like I just started to go like, oh, nothing's changed since 1965, or we've changed so little that all the same problems exist. So that was that was like how I got into being interested in how our blower door works and what it tells us. And I thought it would be funny if I asked you two to also tell the story of your first time.
The first time.
Which one of you wants to go first?
It looks like
I'll let Peter go, but Peter, before you explain your first time, I have visions of like the instruction manual saying something like it's a 2-person job, and the guy at the blower door grabs the blade and spins it and yells contact, and then he cranks a hand crank to kind of prime the propeller before it actually kicks on.
Boy, so not only have
that was probably after your first use of a blower door.
Yeah, the first blower door had a combustion engine that drove the fan. Well, that's actually funny because some of the early blower doors were pretty clunky. In fact, you said, should it say suck or blow? One of the first blower doors in Texas was through a window, and it was called the super sucker. It wasn't even called a blower door. My first blower door was in 1993 when I started work at the NHB Research Center. And I didn't know anything about the performance of buildings, having just been a builder and remodeler. And there was a project we were working on where we had to know the air tightness of the research home that the NHB Research Center had built several years ago. We were testing 2 different heating systems in it. And so the guy who was trained in blower doors set it all up. And I said, well, should the basement door be open or closed? And he said, well, we have to decide that. And I thought, that's a pretty big decision as to whether you include it or not. And so it was really interesting that the blower door measures certain things incredibly accurately, but there's a bunch of stuff that we do that means that we have to get our measurements as accurate as the blower door and pressure gauge measurements. So we're going to have an interesting conversation about calculating floor areas and volumes. But the really
that's a garbage in, garbage out kind of equation.
Yeah.
Yep.
But the really interesting thing is that we were testing 2 different types of heating system, a radiant ceiling system and the conventional forced air. And we were really scared to go tell the guy who was, in part paying for the research we were doing that the house was really leaky. And because this house was a modular home that was really leaky. I forget what the number was, but the manufacturer of the radiant heating system said, oh, that's okay. And I thought,
Why?
What am I not understanding? That the guy who's, wants us to test the radiant ceiling system isn't upset that the house is really leaky. And if you think about it, the leakiness of the house was going to penalize the forced air system proportionally more than the radiant ceiling system. So he didn't care as much about the air tightness of the home as the forced air manufacturer would have cared. Gave his system a bit of an advantage. So the interesting thing is that the results of my first blower door test made me even less sure about what I understood about how buildings work.
What about you, Steve?
So mine aren't as scientific as yours might be. My first experiences with blower door were probably just right after Peter's time. It had to be like 95, 96-ish. And I would almost,
by the way,
yeah, and I would almost guarantee they were with a good old friend, Neil Moyer, who I would consider the godfather of the blower door. I know Gary Nelson invented them and all, or built them, engineered them, and all of this, but at that time, there was probably nobody that had more knowledge about a blower door and its relationship in a house than Neil Moyer.
He and John Tooley did a lot of that.
And those guys there. Yeah. What was that? What was the name of their North Carolina company down there?
Advanced Energy?
Advanced Energy. Yeah. They were involved in the first Builder's Guide. Didn't they do that in partnership or something? Mm-hmm. So mine are more kind of jokingly funny. We got sent down to Mississippi, and when I say Mississippi, it wasn't Jackson. It was like Tutwiler, Manatee, where populations are measured in hundreds, not thousands. Actually, Manatee might have.
Are those real cities in Mississippi, or did you make up those?
No, and there was one that I can't remember, but I stood right. The person we were with said, at the back of this building by the railroad was where the blues started. And I forget the name of the guy that he said, and I don't know if that was Tutwiler. There was 3 towns that we went to, and I can't remember. It was Rosedale, maybe, was one of them. But anyways, so one of them was the probably, I would put it in the case of one of the most feared women I've ever met. Neil Moyer. Your wife? No. My okay. Wife is a dreamboat. I don't fear her. But we were down there, and there's a whole bunch of stories that I just can't tell because they're probably not the most politically correct. But let's just say that the day kind of ended where this 40-ish year old single woman invited us to dinner, and Neil Moyer and I were scared to death and had to come up with excuses. And some of it might have had to do with her language, her stories, and the swastika tattoo on her right arm.
So, Steve, the specter of Neil's not a small guy either. The specter of you and Neil combined being afraid.
Yeah. Well, when we're together next time, we'll have a conversation about the actual stories of like what she said when her daughter walked in the house. And anyways, but yeah. It was really scary. But the thing I remember about her house too was Neil calling me down the hall to look inside the laundry closet. Well, inside the laundry closet, some genius decided to also put the naturally aspirating water heater. And on the side of the water heater, and I do have pictures of this somewhere, I have to find them, but there were burn marks probably like 24, 30 inches up the side of the water heater from the flame rollout on the water heater, because it was put in the same closet as the dryer.
So when you turn the clothes dryer on and depressurize,
you're basically sucking on that flame that's underneath the water heater.
It may have helped their clothes dry a little more quickly.
Yeah, and there were like piles of clothes in there. How this place didn't burn down is baffling to me. Yeah. Let's just say that. That was mystery number one. One of the houses we also went to, it was during the day. We were doing an energy assessments on these for the state of Mississippi. And it was a manufactured housing, metal skirt. And Neil's like, hey, you got to go down underneath this thing and get the insulation and stuff. And it's like, hey, okay, no problem. You know, it's like 3 feet off the ground. I'll pull back the skirt, crawl around under there. Well, I pull back the skirt, crawl in about 3 feet, shine the light, and I see the ground move. And when I say ground move, I'm not talking about like 1 square feet. I'm talking about the majority of footage underneath this prefabricated house just seemed to kind of shift left and right, back and forth. And there were long, thin, skinny things down there.
Kind of like Indiana Jones.
Yeah. And I hate snakes. They are, I can tolerate almost anything, but snakes are not certainly at the top of the list. And I just came like scooting out of there. And Neil's like, what the hell? And I was like, Neil, I am not going in there. The ground just moved. And he just kind of poked his head, says, yep, there's insulation in there. Looks like probably about R19. Good. All right. Nail up the skirt. We got that.
R2 or so.
Good assessment. So, but the last story I also had is I remember we were doing a blower door on a church, and we set up like 3 or 4 blower doors in the front doors. Like we had a guy there like nailing 2x4s to build this frame. And all I remember is when they turned them on, that the thing was like shuddering and trying to fall out of the opening. So I went and grabbed one of the loose church pews and leaned it up against the frame. So we have this picture somewhere of these 4 blower doors inside this opening with a church pew leaning up against them at 45 degrees, kind of
barricading zombie style.
Barricading, yeah, at the church. But we were able to actually get readings there. So, anyways, Neil was he was a really great educator, very much like Joe. He would sit there and endlessly tell me all the nuances of blower doors and talk about it and what to look for and this and that. And I mean, at this time, I was a young architect, right? 95-ish, 96-ish. I was probably 2 or 3 years out of school. So I was somewhat like Jake, like, what the hell is this big fan and why do I care? But here I am working with the guy who probably cares and knows the most about it. So very fortunate. And I run into him every once in a while at a conference and stuff. So it's
Jake,
he's a great guy.
You owned a DG 700, the digital gauge 700 from Tech. Did you buy that first before you bought a blower door?
No. So I bought it as a unit, as a package deal, and I still own it. Actually. I hope that Travis listens to every podcast. Travis from Catalyst Construction has it on long-term loan right now. I have a RetroTech, the 5,000 fan with the DM32 now, and all I can say is they're very comparable. They both give me the readings that I need to get, and I'm doing so little like outside of the realm of just testing an envelope that I'm not sure if I see a benefit one way or the other. I think they're both just very competent devices.
Yeah, people will learn this from if they go back to episode 19. But to me, I started out with the DG700 from TEC, and I didn't have a blower door fan. So I used a window fan, and I could depressurize, small homes to like 20, 25 pascals. So the first blower door test I did they weren't quantitative, they were qualitative. I just used it to depressurize the house enough to go find the leaks as opposed to actually measure. And that's kind of interesting because I remember the second time I did a blower door test, Steve, was with Koda Ueno at Building Science Corporation. We were in Houston testing a bunch of Building America homes. And, Koda wants to set up, the software, and he wants to run through the multi-point test, and he wants to, after he's done and gotten the measurement of the CFM50 at 50 pascals negative, he wants to go find the leaks. And the other guys are like, hey, we got the 50. Let's go to the next house. Coda's like, no. It's important that we understand, the relationship between the leaks and their size and their locations, and they're all rolling their eyes. And Coda was saying it's where the leaks are and how big they are that's just as important as the number. So that's always been one of my pet peeves is that, once you get the number, people blow and go and never really learn where the leaks were or how many of them were easy to seal as compared to really hard. And Coda was like taught me, no, it's both qualitative and quantitative.
Well, I can tell you that it's funny because you bring up Coda, because I was just thinking about the next thing I was going to say. And, part of me with the blower door is I have somewhat of an aversion to it, to blower doors in general. And part of it, I think, is because in my earlier days, I was intellectually intimidated with the blower door, because my only association with blower doors in those days was Neil Moyer, Coda, Armin, and, these are guys that can talk circles around people about pressure and, testing and all of this. And I'm just this young architect sitting there going, It was more like, Steve, why don't you go out and do blower door testing with these guys? Not because I had something to add. It's because I could carry the blower door in the frame in one shot, up the stairs. So yeah. I got to travel with these guys and do that. And I remember my first time with Coda, and I don't know if he did this with you, but, Coda's certainly a machine. He geared up like he was going on a SWAT raid, right? Like he had a clipboard that was double Velcroed to his thigh so he could jot down notes while he's doing things, and like had his bat belt, like flashlight and, this grappling hook and everything, so that he was able for almost any situation at a moment's notice to find that air leak and, make some kind of adjustment. Or he is the epitome of like preparedness and operation. It's absolutely amazing when you get a chance to do anything with him. It's a trip. And I do remember, Peter, we were out, I think it was like Vegas or something, and Phil was with us. It was me, Phil, and I think it was Coda. And, Coda's relentless. He has to get every measurement and take everything. And Phil and I were just sitting there going, the go-kart place is closing in 2 hours. We got to get out of here, Coda, because we wanted to go ride the go-karts tonight.
Good time with the go-karts.
And Coda's like, well, we should really turn this around and do a negative test, and we should do this and that, and then we need to get the pressures across the bedroom doors, and it's like all of this, and it's like, can't we just guess at it? We'll give an educated guess. The go-kart place is closing. So,
all right. So let's talk about what ACH 50 means, just as a base to the conversation. It means air exchanges per hour at 50 pascals of pressure, meaning if you pressurize or depressurize the house to 50 pascals of pressure, all of the volume inside the house doesn't exchange more than 3 times per hour. And that's the way the code still reads for the majority of the United States. I think it's climate zones 1 and 2 is 5 ACH 50. I don't know what the 2021 code update looks like on that, but I heard a rumor that it was going to be 3 across the entire United States.
But there's also local municipalities can lessen it, right? Because I think it was like North Carolina, even though it was 3, there's a bunch of communities that relaxed it to 5.
Yeah, or that haven't even adopted, So that kind of allows people to cheat by making their house bigger, right?
Yeah.
If we're talking about total volume exchanged, if you increase the volume of the house, then you have to leak more air to get to the same, or potentially you can leak more air, higher CFM at 50 and have a lower number. Yeah.
So it's interesting that, there's 2 channels on the blower door setup. One of the pressure channels measures the difference in pressure between the inside and the outside of the building. And then the other one is the pressure across the fan. which gets converted to cubic feet per minute. So that's the first thing that's really seemed weird. Well, wait a minute. If you're trying to measure the flow across the fan at 50 pascals, why don't you just measure the flow, right? I mean, put in a flow gauge into the stream of air and measure how fast it's moving. And, we were talking to Gary Nelson. He said, yeah, but that's a very difficult measurement to do consistently. And you have to know the fan curve, how much air moves per rotation of the blades. And it's really interesting that it's actually easier to measure the pressure across the fan and convert that to cubic feet per minute airflow. That's more accurate than actually measuring the airflow.
Which is why those little rings, you have to make sure you enter the correct ring, right? Because it has to know the space that it's measuring that pressure distance or difference in.
Yeah, and the other thing that's interesting is, when you pick up a fan blade, right? How many blades? How much are they curved, right? Because like on a prop airplane, you can't change the number of blades, but you can change the pitch, the angle of the blades, right? So they bite harder when you're taking off and less when you're in flight. So you can change that relationship between the way the blade cuts the air and how much air is being moved. Well, you can't do that with a blower door, right? It's a fixed blade. So that means there's a range of RPMs for the fan where there's the optimal relationship between how the blade cuts and moves air. And so rather than speeding or...
For optimal reading, right?
Pardon me?
That optimal relationship is so that the thing can take the best measurement.
The most accurate. And so this is kind of weird because you would think that if you picked a really good fan to take care of lower or higher flows, you would slow the fan down or speed it up. And we do that, but within a certain range. It's actually more accurate to put in a ring to keep the blade spinning faster than it is to slow the fan down. And I remember asking Colin Olson about this at TEC, and I said, yeah, but if you pick the fan that's 18 inches in diameter, and now you're necking it down to a hole that's like 4 inches, doesn't that create a lot of turbulence? And he said, well, think of it this way. If there's a bunch of rocks in a stream, above the rocks, the water is very smooth as it necks down through an opening in the rocks, and it's only downstream that you get all this turbulence. He said, same with a blower door fan. As you pull the air through, the flow is really, really steady and consistent around the hub. And so that's why putting on different ring sizes doesn't create a lot of turbulence. And I didn't, I'm not a physicist, but Gary and Colin both are. And it's just, the cool thing about those guys is they're, PhDs in physics, but they're actually engineers at heart. So all the people we know that are like the leaders in building science, the thing that's really cool about them is they have incredibly strong academic credentials, but they're all engineers at heart. They're all like, okay, that's good to understand that principle, but how do we make that work for us and understand how buildings work? So to me, they're really, all the cool people we know that are 10 times smarter than we are, they're not just academics and they're not just engineers. They're the best of both.
That conversation about being able to, I called it gaming the system by making the house bigger. It's a challenging thing to compare different size buildings then. We finished a house in August that tested at 0.57 ACH50. We're very happy below that passive house requirement. By the way, passive house is 0.6 at ACH50 for those that don't know. And then the house that I'm in now, that I'm recording the podcast from, is my personal house, and it was 0.43 ACH50 a couple weeks ago when we got our final. And those are third-party tests. I had somebody ask me if I was third-party testing, and I was like, oh, are you accusing me of not putting out real numbers. Well, that 0.57 is a hell of a lot better achievement because that house is 1,200 square feet. And the house I'm in right now, because it has my office attached to it, is like 3.5 times that size.
Yeah.
So that 0.57 is more of an achievement.
So it's because the relationship between surface area being a squared function and volume being a cubic function. Martin Holliday has a great blog on Green Building Advisor about should we move away from ACH 50? And it's because leaks aren't about volume, they're about surface area. And so there are metrics we can report that are CFM per square area, right? And a lot of people say they're a lot more meaningful than using the volume-based ACH 50.
And that square area would be, in Martin's proposal, would that be area of the envelope?
Yeah, area of the enclosure. Because that's a better measure of air leakage rather than going to a volume. Because it's not the volumes that really leak; it's where the leaks occur on the. But so that gets into when we get a CFM 50, that's a really accurate measurement from the equipment that we've paid a lot of money for, the blower door fan and the digital pressure gauge, what do we do with that number? Well, now we go around and we measure the volume of the house. I dare anyone to measure the volume of even a simple house as accurately as the blower door fan and the pressure gauges, their accuracy. I was just in a house that's 5 levels, 8,000 square feet. It took me 3 hours to estimate the volume of that building. I mean, it's got a silo, 3 stories, that's attached to a rectangular shape. It's got all kinds of
You're sure this wasn't a barn?
Well, it kind of was modeled after a barn. It's up in ski country in Vermont. But it's an incredibly geometrically complex building. And I'm sure that my measurement of its volume, is plus or minus 10%. Now, if you had a new home that you had like in BIM, there's probably ways to generate the volume really accurately off of a 3-dimensional model. But when you go and measure by hand, measuring even just floor area accurately is, it takes time and effort. So we get these really, really high quality, accurate measurements from our equipment, and then we divide them or manipulate them with measurements from a job site.
So we've had that conversation in-house before. I was helping one of my HERS raters measure a house because I hadn't done it before he got there. And he's like, well, this room is 1411 by 76. That room is, and he said the measurement. I said, okay, well, what about the 6-foot doorway between them? Like, that's another 4 inches by 6 feet by 6'8" tall. Like, how are you calculating all that? He's like, well, would you rather we just measure the exterior walls? And I said, well, are we counting the stuff on the outside of the drywall? Because the drywall is not an air barrier here. And if so, are we counting the studs then? Are we assuming that there's 15% framing? Like, where do we make that? And we just measure the floor. And I was like, okay. I mean, at least then I know that all of my houses are rated in the same way that every other house that he rates. And so we just decided to do that when we test envelopes without drywall and stuff like that, that we're just measuring to the sheathing then for that conversation. We're assuming there is no framing members or windows or anything like that. We're just measuring. And so it's like, I feel like I just had to pick a standard, and I've just done that for all my houses when I test, so that I'm at least testing all of mine the same.
When I was at the NHB Research Center, there was a group under a contract to work out an ANSI standard, ANSI, ANSI standard for measuring and recording floor area. And this was being driven by the realtors. They wanted everybody to measure square footage of homes the same way. And that doesn't even include volume. These guys went on for months arguing about how to measure just the floor area of a building, which is actually a lot easier than doing volume. So you would think that, how hard is it to measure floor area or volume of a building? And, if you've got a real small, real simple cape with no cathedral ceilings and no bump outs and, it's pretty easy to get an accurate volume measurement. But we have a lot of really complicated buildings where that's not quite as easy.
Yeah. But Peter, even with the simple house, this is where I come in with the opposing view. I speak for the listeners.
I wonder if they agree.
What did you say? I wasn't listening.
Yeah, exactly. But my take was always, even if you took the simplest house, and let's say we would get let's do a tool shed, 16 foot by 20 foot, no windows, one doorway. What's the chances of 10 people doing a blower door test and having any two of them calculating the same volume and having the same input, right?
Yeah.
And getting the same result, right? The same result, I would say you're going to get 10 different results. Out of the 10, you might get 2 that have the same inputs, exactly the same. So it's one of those things that, like Jake, you just mentioned where you did all the tests. Unless you go into the development and you're the one person that did all of it, you really don't know what the comparison is, because there can be, I see this crap all the time you see it online. There's one that comes to mind where I was arguing with the guy, and that's a surprise. But online where
Voice of the people.
someone's got to stick up for the people. And, but they were arguing something like 0.1 air leakage. And the building had a 10-foot wide by 9-foot garage door. And I was like, hell no. You have 1.0 of leakage around that garage door by itself. Oh, well, we sealed it up really good with, some good garage door gaskets. I said, I don't care. You can buy the best golden garage door gaskets out there.
So they were counting the garage volume because it was heated?
Well, it was the building. The garage door was somehow part of the conditioned space,
Like garage door in the kitchen sort of thing.
or something. It wasn't quite that, because it was industrialized. But it's just, I don't know. It was just really weird that, and I use that as an example because that's one of the ones that rise to the top. But you hear some of these insane numbers, and you look at the project and go, there's no way that a house with that kind of cut up roof is getting that kind of number. And so then you wonder, okay, who's doing the inputs, and where is all this coming from?
There's got to be studies about exactly what you're talking about, Steve, like how to reduce the variation from tester to tester, and where it's best to spend your time. Like, don't worry about 2 decimal places on the gauge. Do more accurate measurements of the building,
right?
So that you honor the accuracy of the equipment. But this is most of the blower door testing I do is on existing buildings, and for me, it's way more important to understand the nature of the air leaks and their location than the number.
Yeah. And you're just trying to get in the ballpark, because the chances are in existing buildings, all of the numbers suck, right? You don't go in there and go, oh, wow, look at this. This 60-year-old building, 1.2, that's pretty good. No, they're all at like 10 or 15.0, right?
Yeah.
Or worse.
Some of the programs on existing buildings require you to get a before and after number to demonstrate percent improvement, right? And so you do need an accurate early one. But in a lot of instances, again, I'm setting up the blower door to understand the air leakage. No one cares about the number, from a diagnostic point of view.
So you bring up a great point, Peter. I push really hard to be involved in the design phase of a project, and I push really hard to be in charge of writing a scope.
Borderline bully, I might say.
The person I work with the most is calling me a bully. And so one of the things that I write in scope of work for our remodels is we're going to do a blower door test before we start anything. And we're going to do a blower door test when we're done. But it's like test in, test out. And that's on even projects. That's on every project where we're going to touch the envelope at all. And on projects that air leakage is not necessarily important to the client. Because I'm going to say, well, we're going to prove that we're at least not making the house worse. That's it. We had a recent project where, and I don't know the exact numbers, I had to look them up, but it was a 3/4 of a house remodel, and we did the energy audit program through the city, which requires the same thing: test in, test out, prove that we did anything better. And it was like 7.5 ACH 50, and I realized that as soon as they did that test, I was like, oh wow, they have a tuck under garage that they didn't show me when I came to look at the house the first time. And there's nothing but diagonal sheathing and hardwood floor between the tuck under garage and the kitchen and living room.
Right.
And I was like, and then there's just drywall wall that like there's a floor drain in the basement that the wall was built over top of. So like you could just stick your hand from the house and into the garage. And so like we moved things around. We sealed everything up. We actually, just for insulation purposes with a little bit of air sealing benefit, we foamed the wall between the house and the garage. And then we foamed the rim in the garage. And then we laid Advantech over top of the diagonal board sheathing and taped all the seams on it and then installed the new hardwood floor. And like we did a lot of stuff to try to separate the two elevations and cut down on some air leakage. And it was like 7.2. Like we went from 7.5 to 7.2. Like we cut like 40 CFM or 150 CFM, something like that. Like an almost nothing number, it felt like. And I was like, well, I'm not sure what I was expecting, but they have an attic fan and they have an attic staircase and they have old windows.
Yeah.
And like, I was like, I guess it makes perfect sense that like I didn't cut down on much leakage because my problem that I was solving for wasn't that much leakage. Like those garage doors in the basement that were behind a door that led to the garage weren't leaking anywhere near as much as that attic fan or that attic access.
Yeah. And, this brings up that just about every time I'm running a blower door, I'm doing infrared camera work, if not fog testing as well. And part of that is, diagnostic and scientific. But, if I go tell the homeowners, well, you got a really leaky house and, you're at, 15 ACH 50, they go, that's a shame. And then you show them infrared photographs and now you start to get their attention. But increasingly, I'm finding that the way to convince people they need to do something about how leaky their houses are is fog testing. That always gets their attention. When they see the actual...
I love a good fog test, by the way.
Well, I'm not surprised. You spent a lot of time like in the fog, so...
Okay, so I was...
It's unbelievable.
We also do fog testing, and just so you know, if you can go to Home Depot or Lowe's or one of those big box stores during the Halloween season, you can buy a fog machine there much cheaper than you'll find one online. I think we got ours for like $60 the 2 or 3 days after Halloween. And I bought the Go Juice that has to go in it. And we've done like 8 or 9 houses now with it. And I'm only halfway through that one, like $20 to $25 gallon of, we call it fog juice. But
yeah, that's funny.
I was scrolling through my phone here, Peter, and I wanted to, I saved this text message comment.
Oh, like I'm not here, but hey, you just go and have a conversation with Peter.
Okay. So I texted Peter this at 8:30 one night, and I said I'm not looking for a response tonight, but I've been kicking around this in my head for a while. When we blow our door test at home, we're not applying equal pressure, or we're applying semi-equal pressure across the envelope, which gives us a reading as to what the leakage is. but that doesn't directly correlate to natural pressures inside the house. And so things like, a can light might leak more under natural pressure than it does under the blower door pressure because of stack effect and things like that. Let's talk about that real quick.
Yeah, I actually, believe it or not, I actually know what one can light, a non-airtight can light, is worth. We measured it in Sacramento, me and Phil, because we did a blower door with them open, and then we taped them off, and we were able to extrapolate what the value is. It's about 20 CFM.
Is that brand and manufacturer specific?
Well, I can get you the specs on that light. I have them somewhere, but smart ass.
So I wanted to hear your perspective on it, Peter. I liked your response, by the way.
I don't remember what it was, but
that's okay.
Yeah. So the cool thing is that, the whole blower door concept is based on Pascal's principle of pressure, which means that if you have a vessel or an enclosure, as soon as you depressurize it, the air molecules communicate at the speed of sound so that the pressure is equalized everywhere. So the blower door is an ideal use of that principle. When we talk about how air moves in and out of buildings, the pressure on the building is not the same anywhere, right? And it varies with climate, it varies with wind, it varies with how cold it is because of stack effects. So that's, the blower door is the best thing we have to try to assess the air leakiness of a home, but it bears little relationship to the way air actually leaks in the building. For one thing, we're depressurizing, which means that we're pulling air out of the building. And in cold climates, there's cold air being pulled in at the bottom and warm air being pushed out at the top. So the way that the air leaks, we're just identifying the leaks and gathering all of them together in sort of a summary number. That's really not how the building actually leaks air. So I don't know how I did compared to the first time around, but
that was pretty much the same as your text message, other than this is not really suited for a text message. So this is a surprise question that I didn't prep you guys for. So I thought I would ask it from the slimy contractor perspective. How would you cheat a blower door test?
Well, so
Can certainly lie about the inputs.
Steve's muted, and he doesn't remember that.
Can certainly lie about the inputs.
You could just lie. I like it. It's simple. It's elegant.
Well, you said slimy. You said slimy contractor. So that's to me a contractor without a conscience, right?
Well, there's the big question about if you have a home with a basement, should you be counting the?
Yep.
Yeah, open the door.
Yeah, and it's tricky because some people say, well, we really don't condition that space.
But is it part of the envelope?
Yeah. So, you can answer the question different ways depending on whether you want to include that volume or not. Because if you include that volume, it's going to it's not going to change the CFM 50. It's going to change the ACH 50, right? Because that's a big volume to rule in and rule out. And I don't know about your guys' experience, but I always do a blower door test with the basement door closed and then the basement door open. And in many, if not most, if almost all of the homes, the number doesn't change much. And the only way that number should change a lot is if there's good separation between the basement and the rest of the house, which there almost never is. So opening and closing that door, you would think that a door that's 6'8" and 2'8" would represent a big change in the total leakage of that space. But there's so many other holes between the basement ceiling and the rest of the house that the number doesn't change that much. I did have one house where there was a cathedralized attic that had an exterior door at the walk upstairs. And we were able to identify the attic as a really big source proportionally of the air leakage because there was good separation between the rest of the house and the attic. But I rarely see that for the basement.
And another reason why that basement leakage doesn't greatly increase too is because you're, for the most part, testing concrete. Like you're testing when you add in that basement, you're not adding in a bunch of sill plate connections that weren't already close to being inside and things like that. Like you're not getting any air leakage through concrete.
Yeah, that's interesting. And you may get a lot of air leakage at the rim joist, but with the basement door open or closed, you're probably still picking up that rim joist, right? So you're right, Jake. There's not much leakage from the majority of the surface area of the basement. And that portion at the rim joist that you're probably still picking that up pretty easily because of all the penetrations, linking that rim joist to the first floor. That's interesting.
Why'd you choose to say linking instead of communicating there, Peter?
Confuse us.
Variety of word selection.
Okay. Just making sure there wasn't something that I wasn't following there that you were trying to make a determination.
Yeah. No, there's
Jake
Sometimes I
looking
feel like
for
I'm trying to catch
underlying
up.
meaning.
Yeah, exactly.
You're reading way too much into,
Just making sure.
my word choices, I guess.
So, Peter, who invented the Pascal, or where does it come from?
Well,
He's been Googling. That's why he's not talking. That's why I hadn't been talking.
I hate you.
I'm assuming
Let's just
that
start with that.
Pascal's principle was discovered by Pascal.
Blaise Pascal.
Blaise?
Blaise. Blaise.
ISE.
That's funny because I thought that was a feminine name, but I think it's both or more.
It's actually a pretty cool name. If I was still having kids, that would be up there. I'm Blaise. It just sounds like you're a fun guy, right? I'm Blaise. Hey, nice to meet you, Blaise.
Yeah, you spell it like Blaze, so maybe that's why you like it.
Well, it's AISE, but
Yeah.
And it's defined as 1 Newton per square meter.
Yep. So it's a force.
What's it
internal.
equivalent to? What's it equivalent to? 10 what? This is Stump Peter before the end
This
of
is
the year.
Wikipedia is what this is.
I don't know what 10 pascals
It's
is equal to.
a bar, BARYE. 10 bar is worth 1 Pascal.
Not millibars? It's 10 bar?
10 bar. What the easiest way that I've always remembered it, Joe expressed 1 Pascal as the pressure exerted by you dropping a piece of paper on a desk. One piece of paper.
Well, that's what's crazy about the accuracy of a blower door or a pressure gauge is it's measuring incredibly tiny pressures. I mean, think about it. There's about 50 pascals in 1 pound per square foot. And the other thing that's weird is that, so what's 1 atmosphere, right? Which is the force pressing on all of us here on Earth. It's like 110,000 pascals. So we feel it as nothing, right? But there's a lot of force being exerted by the atmosphere on us. And so 1/100,000th of that pressure is what we're measuring the accuracy to. Actually, the pressure gauge is measured to like plus or minus 0.5 pascals in that range. And, I was talking to Gary Nelson about this. What's really cool is, like, Gary, how does a pressure gauge measure that accurately? And it's actually a silicon wafer with a voltmeter stuck to it. And as you exert force on it, that translates to an electrical current in the silicone. And as that disc moves, it picks up and expresses the pressure difference as a very tiny voltage. And the really cool thing about those, called piezoelectrical measurement, is that it's incredibly durable, and accurate. So that's why we have these pressure gauges that measure incredible ranges of pressure and very accurately. And these pressure gauges last, a really long time. They need to be recalibrated, but they're accurate and durable.
It is very interesting, actually. Okay, I think that's a good Nerdville place to leave this episode. I have a feeling that we will revisit blower door, maybe a blower door tips and tricks. Oh, I forgot to say, my little cheat for blower doors. If you're depressurizing, use casement windows, because then your windows will test better, because they'll pull in on the weather stripping. And I don't think that one's slimy either. Casement windows are also prettier than double hungs in most of the houses I build.
Yeah, double hungs leak like a sieve. They're horrible.
Yep.
I was just thinking, Jake, can you imagine the amount of energy Peter expended the evening before the recording with Gary Nelson?
I was terrified.
I can just see you like
Really? And happy and
that's
excited.
that's like a steam engine, like going 200 miles an hour, just like really chucking, and like you have all boilers fired at that point.
Well, the cool thing about guys like Gary is that he's been devoted to buildings all his life. And,
no, I get it. It's cool.
And he should
totally
be
on
retired,
board
but he says, no, I'm not retired. I'm just on a different work schedule.
Yeah, people like that don't retire. People like that just kind of fade away, but they don't retire. But it's like if you sat down next to Bill Belichick, how can you not talk about football, right? You can't. You'd have to be excited.
I wonder what the pressure is inside of football.
I don't know.
Depends on whether or not the Patriots are playing.
Yeah, I think they determined that years ago, right? But hey, I know, Jake, you were looking at me. I was videoing. So this is like the technological world we live in. It's just so cool. I'm fascinated. I know you guys won't be as fascinated as me, but we're sitting here, we're doing a Zoom call for a podcast that we'll record that literally thousands of people will listen to. But while I'm doing that, I'm streaming live a site camera and watching the excavator go through this house and tear the house down on a project. So
you're multitasking with us?
I am multitasking. I read this. You're not going to believe this, so you might want to seatbelt yourself in the chair. But I read this book, and it's called One, and it's basically the one thing you should worry about. But in there, he talked about one of his baseline arguments was multitasking's a bunch of BS, and that we spend about a third of our time recovering from things that have taken us off what we're supposed to be focusing on.
Mm-hmm.
And that we waste a lot of time with that, and the fact that multitasking just doesn't. And he said, pick the one thing that's the most important thing, focus on that. That's where success lies.
So I actually believe you, Steve.
It was interesting.
Focusing on the podcast? Is that
look at us. I mean, we're doing blower doors, and I'm throwing out book club stuff because that's how much I care.
And I believe the title of that book is The One Thing.
You
recommended that to me, and I read it. It was good.
Yeah. See? I'm doing book club now, Peter.
And now book club is over, and so is the podcast. I'd like to say thanks for listening today. Don't forget to leave us a 5-star review on iTunes, or keep it to yourself if you're anything less. Don't forget to subscribe, because the subscribers is how we know how many people are listening. And don't forget to like and follow us on Instagram. It's the UnBuild It Podcast on Instagram. I'm Jake.Bruton on Instagram. Stephen Basic Architects on Instagram. And there's Peter.
I have to look it up each time.
Yeah. You know what's funny? I told Jake he should change his name. right? He's getting to that age where it's like having how can I say it?
Flair?
A more perceived influence, right? Just by kind of initially meeting him. If he changed Jake Bruton to Jacques Bruton, right?
Why is it not that's the architect's perspective?
I thought you were going to say he should change his name to Blaze.
Blaze, there you go.
Till next time, thanks for listening
I'm Blaze
to the
Pascal.
UnBuild It Podcast.
Thanks, you guys.
All right, pal.